Okay guys, so yesterday we talked about the law of conservation of mass and how when we're looking at a chemical reaction, we have to know that the mass before is equal to the mass after. And the bigger concept that the atoms that create that mass have to be equal. So if I start with 4 carbon atoms, I gotta end with 4 carbon atoms. And so that brings us to our topic for today, which is to balance chemical equations. So I want you to kind of think of a chemical equation like the recipe for a cake, okay? If I'm gonna bake a cake, I'm not gonna use a cup of every single ingredient. Cup of flour, cup of sugar, cup of salt. Gross, okay? That would be gross. And our chemical reactions are no different in the fact that we have the ingredients, but that's not the whole story. We have to give ratios of how much of this for every how much of this. And that's gonna make how much of this and how much of that. And so the big picture is once we have our chemical equation, we have to balance it. In other words, add coefficient multipliers that are going to show us the correct ratio of our ingredients, our reactants and products. So chemical equations must be balanced. We have to balance them in order to obey the law of conservation of mass. None of our atoms are going to disappear. That's not Hogwarts. We cannot just poof and make a chlorine atom disappear, nor can we make anything appear that we didn't have before. So we must balance them so that the number of each atom on the left is equal to the number of each atom on the right. This is the goal. We need to make sure that whatever atoms we have on the left, we kept them and we know exactly where they ended up on the right. So to do this, rather than changing our formulas, because we just spent a whole unit talking about how to write formulas correctly, we can't change the formulas. I can't make flour into sugar just to make it something else. I can't do that. So we're gonna add coefficients, they're multipliers, in front of the compounds in the equation until the equation is balanced. Okay, and I'm gonna have you guys write down the steps for doing this, and then I'm gonna walk you through those steps using some examples from the worksheet that you got. So steps for balancing a chemical equation, and if you need to pause the video at any point, please pause the video so that you can write stuff down. Step number 1, oftentimes, remember the standard says we need to be able to both write and balance equations. So sometimes your equation is going to be in words. We're going to describe the reaction to you. So like we did yesterday, you'll create a skeleton equation and then write all the formulas for the compounds. Remember when you're doing this, like we did yesterday, don't forget about the Hofbrinkels. Okay, hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine, they all have to be diatomic, H2, O2, Cl2. And then, word of caution, if your formulas are wrong, the equation typically doesn't balance very well. And it's very frustrating to spend 15 minutes trying to balance an equation only to realize that the reason it won't balance is because you forgot to crisscross your charges and there's supposed to be a 2 there. So make sure you really check your formulas and be very careful that the formulas you are using are correct. So once we have our equation with all of our formulas, I like to put a box around each compound in the equation. Just as a reminder not to touch anything. CO2 is always carbon dioxide is always CO2. You cannot change the formula. We are simply going to add coefficient multipliers in front of the compound. So we're not going to change anything in the compound. No touchy-touchy. Then we're going to make a list. Just like I would make a shopping list for my cake, I'm going to make a list of all the elements in the reaction below the arrow. You're going to count the left side. You're going to count the right side. So how many of each type of atom do you have on the left? How many of each type of atom do you have on the right? And then the last step is to add coefficients. These are multipliers until the 2 sides of the equation are equal for all the elements. And I use MENO for this. MENO stands for metal, ion, non-metal, oxygen, hydrogen. I'll explain how that works when we do the problems. So this is number 1 and 2 on the back of the worksheet that you picked up yesterday. Let's just go through these steps together. So step number 1 was if it's in words. This isn't in words. We've already got our formula. So we're going to bump down to step number 2, which was to put a box around each of my compounds. So I'm going to put a box around BaCl2, can't touch this. Skip the plus sign. Box around Na2SO4, can't touch this. Skip the arrow. Box around BaSO4, can't touch this. Skip the plus. box around NaCl. Can't touch this. So nothing inside those boxes can change. Everything in those boxes has to stay the same because those are the correct formulas. So next I'm going to make a list of everything I have. So I have barium, chlorine, sodium. Now, pro tip. Notice how this polyatomic ion, sulfate, SO4, crosses the arrow without getting taken apart. It's still SO4. When that happens, as long as we don't take it apart, we can put it in our list as SO4. Okay? Now, sometimes we do take it apart, and then you have to list each of the individual elements separately. But since we didn't take it apart in the equation, we can leave it as SO4. So now we're going to count the left. On the left, I have 1 barium. I have 2 chlorine. I have 2 sodium. And now this 4 is part of the SO4. I've only got 1 SO4. Now I'm going to do the same on the right. I'm going to count my right. On the right, I have 1 barium, 1 chlorine, 1 sodium, and 1 SO4. So this is where MENO comes into play. It stands for metal, ion, non-metal, oxygen, hydrogen. Now the reason we single out oxygen and hydrogen here, oxygen and hydrogen are tricky little buggers because they tend to appear in lots of different compounds in the equation, more than one spot. And that can make them very frustrating to balance. And so we save them for last in the hopes that when we balance everything else, they kind of figure themselves out. Okay, so we always save hydrogen and oxygen for last. So we're gonna start with our metals. The 2 metals I have here are barium and sodium. Barium's already balanced, it's 1 and 1, so that one's okay. So we're gonna look at sodium. Sodium has 2 on the left and only 1 on the right. So I need a multiplier, something that I could multiply this 1 by to make it a 2. Well, to make it a 2, we would have to multiply 1 by 2. So I'm going to go up to my sodium in this equation, but it's in a box, and I can't touch any of this. So I'm going to put a 2 in front of the box. Now, this is just like in math class. If I put a 2 in front of a parentheses, it applies to everything in the parentheses. If I put a 2 in front of this box, it applies to everything in the box. So this is going to give me 2 sodiums and 2 chlorines. And would you look at that? 1 and 1, 2 and 2, 2 and 2, 2 and 2. This up here is my balanced chemical equation. So when I ask you to balance a chemical equation, this is what I'm looking for. I'm looking for you to add the appropriate multipliers that make it so that everything is equal. So this down here is just the work piece. What I'm really looking for are these numbers that you've added to make everything work. So let's do another one. The next one we have is AgNO3 plus CaCl2 makes CaNO32 and AgCl. So let's start by putting each of our compounds in a box. Can't touch this. Skip the plus sign. Can't touch this. Skip the arrow. Can't touch this. Skip the plus. Can't touch this. Nothing in the boxes can change. All right. So let's go ahead and make our list of everything we have. We have silver, and then we have NO3, and we are going to check the NO3 crosses the arrow without getting taken apart. So we're going to put NO3 in as a group. Then we have calcium, and we have chlorine. All right, on the left, we have 1 silver, 1 nitrate, 1 calcium, and 2 chlorine. On the right, other side, we have 1 silver, we have 2 nitrates. Does everybody see that? The nitrate is in the parentheses, and we got a 2 on the outside of the parentheses. That means that there are 2 of the NO3 group. It does not, however, apply to the calcium. It only applies to what's in the parentheses, so we still only have 1 calcium. And then we have 1 chlorine. So going back to MENO, starting with the metals, we have silver and we have calcium. Both of those are already balanced, so we don't need to do a metal. The next one is ion. So we're going to go to the NO3 ion. There's 1 on the left and 2 on the right. So we need a multiplier for the 1. 1 times 2 would be 2, so we're going to use a 2 coefficient. So I'm going to go up to where I have NO3, go to the beginning of the box, and put a 2 in front of that box. But remember, this is like in algebra class. If this is my parentheses, the 2 applies to everything in there. So it's 2 silver and 2 nitrates. So now I fixed my nitrates, but I messed up one of my metals. So I'm going to go back and fix the metal. All right, so I have 2 silver on the left, and I have 1 silver on the right. So I need a multiplier for this 1 to make it a 2. That multiplier would be a 2. So I'm going to go up to the AgCl, and I'm going to put a 2 in front of the box. That's 2 silver, but that's also 2 chlorine. And if you look, now everything is neatly balanced. So this would be our proper balanced chemical equation with the coefficients 2, 1, 1, and 2. All right, so hopefully that's making lots of sense. There is one issue that I noticed that people ran into. What if we have like an oxygen and there's 3 on the left and 2 on the right? What do we do with a circumstance like that? There's no multiplier that's going to make a 2 a 3. So what we do is we go to the least common multiple, the smallest number that they both go into, which is 6. So wherever your oxygen is on the left, you put a 2, and that would change that to 6. Wherever your oxygen is on the right, you would put a 3, and that would change that to 6, and that would balance it. Okay? So that's one trick that my students have been running into today. Let's look at some word equations. All right, we have solid sulfur. This is the first one at the bottom. So this should be your first word equation at the bottom of your worksheet. Solid sulfur reacts with solid iron to form solid iron 3 sulfide. So let's go ahead and put a box around each of our compounds. Reacts with would be a plus, solid iron to form, that's going to be our arrow. And then we have iron 3 sulfide. So that's a compound we need. Okay, now remember, our Hofbrinkels, we have sulfur, element all by itself. So we need to check our list. Is it a Hofbrinkel? It's not. Sulfur is not a Hofbrinkel, so it doesn't have to be S2, so we're just going to write S. Then we have our plus. Then we have iron, again, an element all by itself, not part of a compound. So on this one, we're going to check our Hofbrinkel list. Iron's not on it, so this would just be Fe. Then we have our arrow. And then we have iron 3 sulfide. So let's go to our flow chart. We're looking at writing formulas. Is the first element a metal? Yes. Does it have a Roman numeral? Yes. So the Roman numeral is the charge of the metal. So iron in this case has a charge of 3+. Okay? Does the second word end in IDE? Yes. So this is not a polyatomic ion, this is sulfur, the element. So we're going to look up the charge of sulfur on the periodic table, and we're going to find that it has a 2- charge. So then we're going to crisscross those charges. The 3 from the iron goes to the sulfur. The 2 from the sulfur goes to the iron. So that would be Fe2S3. So now that we have our equation, we need to go through and balance it. So we're going to put this in a box. Can't touch this, can't touch this, can't touch this. We have just sulfur and iron here. On the left, 1 sulfur, 1 iron. On the right, 3 sulfur, 2 iron. Easy fix, easy fix. So we need a multiplier to make this a 3. So we're going to put a 3 in front of sulfur. We need a multiplier here to make this a 2. So we're going to put a 2 in front of the iron to make this a 2. That's a fairly straightforward one to balance. So let's try a trickier one. Okay. We have calcium hydroxide. Let's go ahead and put our compounds in a box. Is dissolved into a solution of, so this is a plus, we're putting them together, hydrochloric acid. Put it in a box. It produces, there's our arrow, that's what we're making. Calcium chloride, let's put calcium chloride in a box. And that's a plus, liquid water. Let's put water in a box. Okay, so now we need our formulas, so we gotta use our chart. Let's start with calcium hydroxide. We have, is the first element a metal? Yes. Is there a Roman numeral? No. So for this one, we're gonna look up the charge of the metal on the periodic table. Calcium is a group 2 element, so it's going to have a charge of 2+. Does the second word end in IDE except for cyanide, hydroxide, and peroxide? Hydroxide is one of our exceptions. It's a polyatomic ion. So we're gonna go to our polyatomic ions chart. Hydroxide, in parentheses, is OH, and it has a 1- charge. So we got a crisscross. So we're gonna take the 2 from calcium, put it outside the parentheses, and the 1 from hydroxide we don't do anything with because we don't write ones. So that's our formula for calcium hydroxide. Next we have our plus, hydrochloric acid. Back to the flow chart. Is the first element a metal? No. Does it end with the word acid? Yes. Does it start with the prefix hydro? Yes. So for this one, we're going to start with hydrogen, and then we need the symbol and charge for the other nonmetal. That's chlor, which would be chlorine, Cl, and the charge on chlorine on the periodic table is -1. So we don't need a number here. Next we have our arrow, and then we have calcium chloride. Calcium chloride. First element's a metal, yes. No Roman numeral, so we look up the charge. We already did look up the charge. Calcium we said was 2+, okay? And then does the second word end in IDE? Yes, it does. So this is just talking about chlorine, the element, which we just looked up is a 1- charge. So we would take the 2 from calcium and bring it to the chlorine. We take the 1 from chlorine and not do anything with it because we don't write ones. So this would be CaCl2. And then of course we all know what water is, H2O. So there's our equation. We worked really hard to put all the correct formulas on there. So we're gonna put them in a box, can't touch this. And I'm actually gonna do this above just so that we don't run out of space and you can all see. Okay, so let's make our list. We have Ca. Now when we went across the arrow, did our OH come with us? It did actually. We're gonna rewrite water as HOH. Still water, 2 hydrogens, 1 oxygen, but it shows us where the hydroxide went. And that's gonna simplify balancing it for us. So when you see water, you can write it as HOH to help us figure out where our hydroxides went. And then we have a second hydrogen that's separate from the hydroxide, and we have a chlorine. All right, so let's count. On the left, we have 1 calcium, 2 hydroxides, 1 hydrogen, 1 chlorine. On the right, 1 calcium, 1 hydroxide, 1 hydrogen, 2 chlorines. So here we're gonna amino. We would start with the metal, but the only metal I have is already balanced. So we're gonna leave that, and we're gonna move on to the ion. So I have 2 hydroxides on the left, and only 1 on the right. So I need a multiplier, a coefficient that's gonna make this a 2. So 1 times 2 would be 2. So I'm gonna come to the right, find hydroxide, go to the front, and I'm gonna put a multiplier of 2. Okay, so that's 2 times hydrogen, so now we have 2 hydrogens. 2 times hydroxide, so now we have 2 hydroxides. So after we do the ion, we're gonna do our non-metal next. So chlorine's my non-metal. I have 1 on the left and 2 on the right. So the multiplier here would need to be 2. So I'm gonna add a coefficient of 2 in front of the HCl. 2 times 1 hydrogen is 2 hydrogens. 2 times 1 chlorine is 2 chlorines. So now if you look, I have 2 and 2, 2 and 2, 2 and 2, 1 and 1. This down here is my balanced chemical equation. Okay, so you are gonna practice these on the rest of that worksheet. So you may use the remaining time in class to complete the rest of that worksheet. And then if you finish with that, there is another worksheet to do as well.